Welcome everyone to another open source Linux live stream here on this channel. Yeah, the recurring theme, boring and unpaid infrastructure, work of toolchain and stuff like GCC and Clang. So still in our T2 Linux distribution, the famous one more thing somehow this year it never stops. And so how it started was Firefox didn't build for quite some months anymore for PowerPC 32-bit or PowerPC 64 with 32-bit default. And because recurring theme here, right, complexity. So the issue was that with all the complexity, we need GCC or Clang, if GCC then Clang 2, and Rust and C-bind gen for C language binding for Rust. All of which for Firefox. And so then, and welcome everyone, Firefox simply, I burned basically probably 8 hours on all this stuff, which is probably why I want to share, like, and subscribe and Patreon and all this good stuff. And as this surely should be simple, right, to fix Clang, to find headers. So the problem was Firefox with C-bind gen and Rust using Clang for the C-binding generation didn't find the C++ headers. And so the crazy thing, I shouted this also a couple of times, as amazing as LVM and Clang are, this toolchain probing stuff here is not. So usually I would expect you configure this like GCC and like for PowerPC, this is directories and it's using that, right? But somehow they didn't want to directly interface with or like interface of parsing GCC specs or so. And also because LVM Clang theoretically always cross-compiles, so you can theoretically also always support ARM or PowerPC on any other target of mixing that, which certainly is nice. And so for that, if you build LVM Clang, you wouldn't necessarily have an ARM toolchain or PowerPC toolchain. So this is probably also the second reason why they determine this here at runtime. And so the problem is, this is also really, I mean, it's simple code. Well, it's sort of simple. So what they do here is scanning directory. Here, like this, like lib, where am I here right now? Spark. So this would be a user. If I have this here also right now in user lib, this should be GCC lib64. If I'm not sure, maybe I didn't build as much yet. Toolchain doesn't matter. So find name libgcc. So because we need this libgccs and the headers, and they live like in Spark and PowerPC and x86-u unknown Linux GNU stuff. And welcome everyone. So so far so simple, right? And so the only problem is this code also looks simple. So they scan here all these directories, basically guessing. So this is not like really using another compiler's configuration. It's just like, yeah, we look at this path and it's probably there somewhere. And it's also crazy that they have here gazillions of, where did they had this, like here somewhere, or I hope I didn't, should this be here? Could also be, yeah, so here for example, so they have here also, they basically have hard-coded all of this stuff. So this is why I don't approve of that. I wouldn't recommend this. I would also not do it like that. Because as seen here live on this channel, this is totally error-prone, right? It may or may not work. Some triplet might be there. And also, if you strace it, it's like it's accessing all kinds of random stuff, like maybe Fedora, maybe Debian, yeah, like maybe PowerPC, Red Hat stuff. It's like, seriously, what the heck? I don't want to have here like Red Hat and whatever random unknown and other random garbage stuff. And so this code looks relatively simple, right? But it is a total pain to debug. I mean, not only... so basically the issue is this works for all normal targets except PowerPC and theoretically Spark, PowerPC 64-bit and Spark 64-bit, which I also never noticed. This is also here in the comments, actually. that here's somewhere written, yeah, so probably this, some versions of SUSE and Fedora. This comment is also wrong, well, the comment is right, but it's actually not SUSE and Fedora, it's also obviously T2, but it's actually the GCC default, right? So the comment makes it sound here like some versions of SUSE and Fedora. PowerPC 64, actually just what I'm debugging here, right? Put 32-bit libraries, libs in what would normally be a GCC install path, basically PowerPC 64, although it's 32-bit. And so they actually theoretically are supposed to support that here with this crazy stuff. Meaning here also, yeah, additional suffixes of all this. Yeah, also, I mean, all this open-coded stuff, right? If Solaris, then that, AMD64, let's try that, let's try another one. If this platform, if Windows is like, yeah, everything in the kitchen thing, just something will probably stick, right? And here they have more stuff, so they have here alternatives. The problem is also, you need to like look all these classes up, what exactly this stuff is doing. This is, yeah, it looks nice and simple, but yeah, what exactly is it doing here? Good luck finding this stuff. It looks super simple, right? They create here alternative 64, 32-bit and x32 of this super rare x32 stuff. And then they have even a custom enum, enumeration for unknown, 132, 64, 1x32, starting with one unknown. So I even tried, I built LVM Clang with debug symbols and attached a debugger last night. And it's like, first of all, even on my highly optimized Ryzen 5950X, this relatively huge sized C++ project, super slow to debug, right? You press tab for some tab completion in the text GDB interface, and it's like even on my system, it's hanging like 5 to 10 seconds. Total pain to work with, like type something, tap, like coffee. And even then, you want to print some stuff like print, like in the GDB text interface, like 2021. Leave in the comments below. Are there any magic improvement things? I mean, obviously I built LVM Clang with 01. Probably I should build it with OG for debugging stuff, or like 00 or OG for enabling optimizations that do not hurt debugging. Probably I should have tried that. But there also was a limit of time last night. Because I built with 01, it's like, yeah, optimize lazy, it's probably good enough for debugging, right? Like they have more. Printing is some stuff like debugging through that stuff here and like printing want, like what does it even want, or is it like want barch or stuff? It's like, yeah, print the stuff, GDB, symbol of variable optimized out. It's like, yes, thank you very much. How helpful. So theoretically this code looks like it has code, and again, I spent probably an hour. So how much contributors time of 20 years of my funny little collecting the most perfect metadata of how to build all this stuff. It's like, yeah, 1 hour there, 1 hour there, at the end 8 hours on one problem, and 8 hours later, right, when I sometimes say maybe I should buy a vintage Porsche like and renovate it at the weekend, because now I would have like a piece of metal that has no dent anymore. Now 8 hours debugging through the stuff, I don't even have a working solution, right? And this is a recurring really depressive thing of source and open source and state of IT and bugs and security and peak bugs. So then I thought, okay, this stuff here is kind of a mess. It's a pain to debug. I actually agree with this comment, like, yeah, this layout is a little bit non-standard. So the issue is that the actual issue is, the actual issue is that if we default otherwise 64-bit PowerPC and Spark, if we default this to 32-bit for performance, so you have like a 64-bit toolchain like you would normally have, and a 64-bit kernel, what you need for PowerPC and Spark 64 to even boot. We at least build all the application and library 32-bit for a little bit of maybe 10 to 20% or so extra performance, even in worst case scenarios, maybe even 50% if you have super cache sensitive, memory intensive stuff. Anyway, this is also what SUSE and Debian did in the past and stuff, not too uncommon, or even this, for those who remember Aurora, Spark, Linux, and this was a thing 15 years ago. Also defunct, doesn't, because who is doing Spark Linux, right, except us. So yeah, not an uncommon thing. And written here in the comments, I said, okay, I thought, okay, this directory layout indeed sucks. because if you change GCC or configure GCC like we do for those two architectures for performance, then you end up with this really strange layout. And I didn't even realize this, right? I only realized this weeks because I never like looked into that. I worked with this stuff, I configured, patched, make, installed, and until something breaks, you don't look there, right? Who is investigating the exact path names and directory names of the stuff until as long as it works, right? So we have here GCC. I hope I maybe also don't have it there because I just cleaned all the builds, just what you do in front of a YouTube video. I actually thought I had patched this now, but of course my patch doesn't work. Lib GCC. So normally this would be lib64, as this is now only lib because of the tool change stuff. So the strange thing is, and I agree with the Clang people that is actually a little bit strange, is you have here usually lib64, doesn't really matter anyway, but you have here this PowerPC64 named folder of T2 Red Hat unknown whatever Linux GNU version stuff, and this stuff is now and this stuff is 64-bit, and this stuff is 32-bit, and I only was messing around here, so usually it looks like this on the last ISO and stuff. So this is how it looks like, and so this is of course a little bit strange that you have a PowerPC 64, and this is also where this LVM Clang code breaks, right? This, where do I have it somewhere of one of, yeah, so this is where the stuff breaks, although it has support for that somehow it breaks because probably bit rot and nobody tested that in a decade or something, or there's some logic typo or whatever the case might be. And so I wasted, so first I debugged the stuff for an hour or two, then I wasted even more, like 3 hours. So then I thought, okay, let's simply change GCC, right? Can't be too difficult to change this directory layout to be a little bit saner and make LVM Clang work, hopefully. And yeah, so much time wasted. On the Discord channel, people have read my comments. This simple thing, right? It should be so simple of, hey, GCC, don't you do this strange 64-bit folder. And so the crazy thing is I had to debug through all this GCC mess here. And the problem is with this complex makefiles and autoconf makefiles and surrounding stuff. So the way how this works is, here is some gen in GCC. And again, so it took me hours to find all the stuff, right? Of course, I knew a lot of stuff. I've seen a lot of stuff, but I also forget stuff. And then often you don't find it, although you have patched this in the past, and like a decade ago, you need to re-find it. And also, you do not necessarily expect it to be that script that you patched 10 years ago, because it's like generating just a list. That looks, do I have that here, gen multilib? So they have here, multilib means you have a B architecture, like 32, usually 32 and 64-bit, and you build stuff like twice or 3 times, not only 32-bit or 64-bit, but also the other variant, or even an x32, the more performance x32 variant. So this is this script is generating the stuff which might be this. This looks simple, and again, it is so complex that even this simple example of M64, M32 is just 64, 32, and equals lib64 in lib. This looks simple, but it can also go more crazy with more crazy CFlex for Spark 64 and stuff. Anyway, you would think, and by the way, this is also in my opinion, this is a toolchain marginality that, in my opinion, since 20 years, I think it was like added to GCC like in 1996 or 1998. It's like over 20 years ago. In my opinion, this code is not perfect. I mean, it's super annoying to debug because there is this gen multilib script, there is configure and makefile, so lots of stuff interwinded. Then you have here, again, I debugged this like 6 hours, like yesterday 3 and today 3, and obviously more than I should. Although you probably want to Patreon and GoFundMe and stuff. Then you need to config multilib, which also I shouldn't edit like that. So this is even another script. So you have gen multilib, then you have configure multilib, and then you have all the complexities of good luck reading and deciphering the makefiles. And a long story short, it looks so simple. And although I patched this, and I would agree with the LVM Clang people, this is for 20 years not amazing. I would say this is a bug, or at least implementation deficiency in the GCC make files. In my opinion, if you configure PowerPC 64 or Spark 64 and you change the default to 32-bit, why the heck should the directory layout change, right? In my opinion, this is a bug. At least it sucks. Even if of course, the GCC people was like, yeah, this is how it's implemented. You're configuring that wrong, or it's deprecated retro. Although it was always this buggy, right, or this imperfect. Because my thinking was, okay, hey, if you configure a multi-arch, B-arch thing architecture with 64-bit, you would always want a same directory layout, and in architecture 64 T2 Linux, you want the 64-bit stuff in there, right? And not this, I mean, this is a little bit insane, right? That you have CPU 64 T2 Linux and there is 32-bit stuff in there, right? It's like, what? And then you have, I hope I said 32, right? 30, and then you have like 64 subdirectory where otherwise, I mean, why should this change, right? Normally the 64-bit stuff should be in there and you should have a 32-bit folder, which is how it is for, do I also have here somewhere like, this is, by the way, how it is for x86. Of course, if you want to check that at home, that is here. And this is how it looks like, that this obvious 64-bit directory has a 32-bit B-arch support subfolder. In my opinion, this is stupid that it changes just because you configure GCC of, hey, I want this bloody compiler to default to 32-bit, that then also the order of the multi-lib stuff changes. I mean, why? I can explain to you why it maybe accidentally, but again, all this code, in my opinion, all this 20-year-old craft of shell scripting, it's even not good shell scripting. And it's like, yeah, 20-year unsuccessful woman distribution guy YouTuber. I would call our shell scripting more readable and stuff. The way this works is, so this is gen multilib here, and the reason this is also not good shell scripting is, in my opinion, it is written in a style that is hard to read. And they even have that here, they have here some recursion, and so they even comment here, this recursive script weeds out any combination of multilib switches that should not be generated. The output looks like a list of subdirectory names with leading, and so they somehow also have, this is written like not very nicely. We need another, also, yeah, a recursive shell script for another recursive shell script, and then they need another recursive shell script to correctly handle positive. It's like, yeah, I rest my case. But somewhere they also even wrote here that they intentionally have written it here like not very modern. It's like 20 years ago, like in 1996 or 1998, they have written this here. Selecting combinations in a recursive process, since not all versions of shell support functions, they achieve recursion by creating a temporary script which invokes itself. It's like, dude. Yeah, there is shell scripting, and then there is shitty shell scripting, and there is readable code, and then there's unreadable code. Anyway, nonetheless, I debugged, as you probably guessed already from this channel, I debug patiently, notoriously, and in depth, all stuff to its end. So what this does, because it also took some extra hours, because I also debugged and read and debugged. Also, in my opinion, more people should do that more often. Read freaking open source, right? Not only configure, make, install, but also read the stuff and review and so on. Something too little done. Because I even had to find out why the freaking heck this happens, right? Because the build script is doing, do I have this still here? Maybe somewhere like, GCC of XGCC. So there are multiple switches of print multi. The switch is also a little bit strangely named. Some with multi-lib and stuff. So by default, so this is my patched version. So the crazy thing is I patched even that. So I spent like another two hours debugging through the whole GCC code because debugging LVM clang is not enough. Also because then I said, okay, let's give up on let's give up on wherever the other mess was. Let's give up on this mess. Let's configure GCC differently. It's like, yeah, that was an amazing waste of time because I first had to find out where they even do that here. And the default is of this stuff is, which they also use internally. And again, I had to figure this out like 1 hour at a time, 1 hour there, 1 hour there, at the end 6 hours gone. That is a common thing in computer science, unfortunately. So print multi-lib. And so that is also, yeah, so that is the x86-64 default. So what this does internally is that directory that we were looking in with no options, and then a 32 subdirectory with -m32. Why they use @ here, I have no idea. Maybe because they use, so they translate this later to dash with SED, of course, in this config multi-lib thing. As you see here, I patched this. This was so this is my patched version, and theoretically, I thought that might work. I also, yeah, the way this does work is that GCC, also this code is highly unreadable. Also 20-year-old stuff, although they now call it C++. This is still some mostly C. Also, yeah, this file is even .c. Again, highly hard to. Also, I really wonder why this stuff also always needs to be so unreadable, right? When I was 20 years of experience, like, oh my god, there's more of this bullshit. I mean, eventually, you already need to open the hard liquor at night to manage debugging through the stuff. Cheers. This stuff here, of course, so this was somewhere with multi-lib or multi-lib. So this multi-lib raw string, so they generate this with this gen multi-libs, and they have here static const char multi-lib stuff here. And so that comes from this gen multi-lib thing, and then they path that here at startup build multi-lib. So this stuff, super hard to follow. This, I mean, they have some op stack, and it's like, yeah, that's, anyway. So the way that this works is that the GCC internally then determines based on these options which multi-lib to apply, and this, for example, means we also have this gen multi-lib here somewhere, and which is like, where did I even have that? Like maybe here, and gen multi-lib here, and so what this outputs is actually, this even outputs a little bit more, which is in object dir object dir GCC. This is in multi-lib h header, then generate. Oh, this is also killing me. I need to patch configure that someday. And yeah, this is how. Wait a second. This is my patched version. This usually looks like that, and even so, this is how it looks by default. And what this, my understanding is, after Guru meditating over this stuff for some hours, is this is stuff to match. So this is like if, let me check. So yeah, so this is a directory name, which in this case is dot, here it's 64. This here is, and then with column they have here the OS directory name. This is then lib64 or lib. And these are the options to match. So this is 64 if M64 and not M32, and this is 32 lib if not M64 and M32. And apparently and obviously they have here the special case of if not, so this is the default case. This is a little bit strange, and it also behaves a little bit strange. Initially I thought that I simply do that 32 for default, but it's in some combination, because obviously it wasn't intended to be modified like that. It's also generating strange stuff if you modify it like this. So I had what I had here. So I figured if I have it like that, it even outputs the right thing. Here, XGCC. So this is what we would want. So that even would work. So after like 6+ hours of debugging and guru meditation, I even patched and configured GCC to do what we want, like 32 as a default and dot for M64. So that would even do what I would want. But now I have the problem, the freaking makefiles don't support this, right? And this is also eventually like seriously, no, I'm 6 hours into this problem. Now I would have like polished some part of my vintage card at the weekend, but we have here now some digital bits and bytes, which no progress, because now I would need to continue patching the freaking makefiles. The problem with that appears, so what I now get, so it builds, it builds into that dot directory and a 32 directory. So far so good. The only problem is it's not supplying this M64. I also found where the problem is for that. This is in config multilib here. Oh, yes, I know. Man, I need to change my VR config. And so the problem here is that they have here a special case, and I tried to patch this, but I think I give up on this stuff now, because it's kind of hopeless. And they also see, I make this video to document how much time individuals and open source contributors, right? For 20 years, I do this kind of stuff, right? Stuff doesn't work together, stuff breaks, like vintage, retro, or actually, when I started, Spark 64 was actually alive and kicking, and so was PowerPC 64 when I started 20 years ago, but RISC-V. But basically, I constantly do this kind of stuff, right? Spending hours on exotic or non-standard configurations that don't work because who is testing PowerPC, right? And this is a black hole, right? It's eating time like nothing, without much appreciation, except you watching, sharing, liking, subscribing, Patreon and GoFundMe and stuff, because this is also the crazy thing, right? How open source people are not wealthy, because unlike Elon Musk or stuff who only are after profit, we wanted to make the world a better place, and only Amazon, Facebook and Microsoft get richer, while we sit here 6 hours on stupid time-wasting problems like this. And the open source community, also, we got ourselves in this place, right? For 15 years, I advocate for more readable, more simple, more readable, more... This is not simple. This is not, for me, with 20 years experience patching multiple things in the GCC, it took me 6+ hours to end up here, right? Just to make the install passes a little bit nicer, to be a little bit more standard and work a little bit better with Clang and LVM, to have Firefox on PowerPC. Which is crazy, right? This, in my opinion, everything should be more readable, more simple. I mean, this freaking stuff here, this is not simple. And multiple generator scripts, I understand why it is there, right? I'm only sure, I get this. They needed some shell script to generate that, they needed some shell script to generate that. And it just shouldn't be so complex. It should also not be so strange. And so on, and yeah, and so on and so on. So the crazy thing is they have special coded here this bloody source dot directory all over the place. And this is why this configuration that I know 6 hours later, I patched this in GCC to theoretically do what I want. And now the freaking surrounding makefile glue doesn't support this. So they have here the dot here, so they basically only, if this multilib, they even use that here, right? GCC print multilib. And SED here is a colon stuff away. So also, yeah, I mean, why do this in shell when you can fork an SED process? But the long story short is now, It builds, it just doesn't do what I want. I mean, GCC does what I want, but the freaking build system doesn't do what I want. And I tried to patch it, right? You would think, yeah, just patch this away, but it's not as easy. I already tried substituting, like basically falsifying that here, like with, it's like, yeah, YOLO. I think somehow, I think the make files, they always build the current dot directory thing always, and they additionally build, this is why they skip over that here, right? If directory equals dot and then true, like, and this is why it's like, yeah, I think, although it looks simple and I'm theoretically there, just now the build system is so unsupportive and old-fashionedly quirked that's like, yeah, eventually 6 + 7 hours in, it's like, I think I go back to the drawing board, leave the paths imperfect, and it's like maybe fixing Clang to somehow find the freaking 32 directory. I think they did they had here /32, or yeah, at least they have, see they have here some /32. Yeah, so at GCC suffix. So this should be, wait a second, we have, also, do they have that basically what we, all right. Also, yeah, so I also thought, so they find here the matching. So this is back to LVM Clang, right? Also not amazing, where we started. So basically neither is amazing. it's so sad, right? It would be funny if it wouldn't be so sad. And so I thought, because they find here, they look here for the matching, like you build 64, you need 64, you want 32-bit, but they don't really look for the matching. I mean, sometimes they make this, do they even write here matching or matches, and to match the tool choice and stuff. But as far as I've seen, because matching, you would think they read the elf magic, right? Opening the file, and reading, like, if the elf header machine stuff is PowerPC and stuff. No, they don't do this. They purely do that here based on the directory. And somehow, maybe this is simply a bug here in the logic, because they have here if one, this, and exists. So they purely determine this here, not based on the elf magic. Or, as I said, I would actually expect that to configure based on the actual GCC print multilib stuff. Again, yes, cross builds and stuff. But again, LLVM Clang, they also support this. I mean, very few people use this, right? They support here with this strange complexity of guessing directories. They support here a use case of everyone wants a cross compiler for, not really. Of like supporting building AVR on every machine. In my opinion, the crazy thing is, actually 10 years ago or so, they didn't have this in LVM Clang. They only had here very little. I mean, most of this was like 10% of this. And 10 years ago in our T2 Linux here, let me still building here, I simply patched in here I actually used here GCC print stuff, and I used here SED, and you can still find this in the subversion history of our T2 package. And I simply patched in here the matching header and library paths, and that freaking just works, right? And now we are, of course, now we don't do this anymore, because in the meantime they have blown up this detection stuff here like by 10 times. It's like not 10 times larger or so. And it's like, yeah, thank you very much. And this is also last but not least, as much as I don't like C, and since 15 years already promote at least light-white, readable, usable C++. The problem with this code looks readable, but even with GDB in 2021, this, maybe I should use a fancy IDE and stuff, but with GDB it is extremely hard to debug, or maybe I should retry with optimize with G, but I mean, you can basically probe here next to nothing, right? Everything is optimized away, and even with O1, and all the other, yeah, as helpful as C++ STL strings are, standard strings, as hard to debug this stuff becomes, unfortunately. And this is certainly something that shouldn't be like this. Maybe I should try how amazing readable to debug Rust is. Yeah, let's maybe take a quick look at the comments, but yeah, just basically a summary of why there sometimes is not a video. It's like, yeah, actually, I'm actually busy with the stuff, but I also don't want to bore you like live streaming me scrolling 7 hours for what the freaking heck is what and looking up LVM and Clang stuff. It's like, oh my god, what were they thinking? I'm a little bit, yeah, this is a little bit sad, as it would have been really cool to have the release now these days with PowerPC 64 Firefox building fixed. Now I wasted so much time on still not having a solution. And in general, yeah, not even, there was already one comment regarding perfection. So yeah, this is also the problem, which, yeah, recurring theme here, earning money with open source, totally amazing. Oh, and recurring theme, right? I had this so often, right? Over the 20 years, every year I had to look into toolchain like ARM stuff, doing strange stuff for our ARM embedded customers, and recurring theme. My customers also never wanted. I mean, who wants to pay money for even, let's say, 4 hours, or for example, even like some real talk here, right? Recurring real talk. If you are in the embedded Linux business, like we tried to be, and you estimate, okay, the problem, improving this path is to be more like this install passes. As simple as it is, maybe you think, okay, how hard can it be? Maybe an hour or two. Maybe you already double that to have a safeguard. Okay, maybe an hour. Okay, GCC and Clang is a bloody freaking code base. Okay, in 2 hours we will probably grab and SED and patch that, right? And what did I say? 2 hours. Let's say 2 hours. You give the customer a quote. Okay, I can fix your toolchain stuff to support ARM version 7, ARM version 8, whatever, or PowerPC or E550 PowerPC, whatever, of all the stuff that can always be there. There always has been something. And then you estimate, what did I say? You estimate 2, you quote the customers 4, and then you sit on this like 6 hours, and it's like, damn, 6 hours in, I don't even have a real freaking building solution, because all the stuff is so vintage, so strange, so hard-coded, or so scripted, yet, I mean, this is also crazy, right? And in one way it is like flexibly scripted, on the other hand it's so strangely hard-coded that it's like, dude, how should I I now could continue to patch this configure multilib thing here, but I also see already I could easily sit here another hour or two on this bloody driver script. Most likely, as I said, as they skip here over the dot directory, so most likely they might build the non-multilib, the primary default multilib, not based on this configure multilib script, but with standard built-in makefile rules. So yeah, this is a thing, right? And then you estimate 2 hours, you quote the customers 4 hours, you spend 6 hours, you don't have a solution, and then you continue with the customers like, yeah, I'm already 6 hours in, it's crazy complex, much more than I thought, so I'm 6 hours in already and don't even see the end of the tunnel, because GNU Free Software Foundation and vintage scripting and stuff. And that is a real problem, right? And paired with, I said this already, most of the time we didn't even win projects, because even with our very underestimated quoting, we were constantly with our Central European salaries underbid by other people around the world. So yeah, the fight to the bottom plus crazy complexity. It's like, yeah. Never answer to the title. No, never stop chasing perfection. If you can, don't let the sloppiness win. Yeah. You're welcome to patch this directory thing to dash writes not shell scripting is a lot more. Tool names. What do you mean? No shell scripting is a lot more annoying to debug. What do you mean? Do you mean shell scripting is more annoying to debug than C++? Couldn't they just written Perl, TCL, or something sort of targeting non-POSIX? Yeah, I mean, I understand. Maybe they maybe they don't have any Perl or Tickle tick in there. And I mean, I understand, but there's also a limit, right? I would actually say, first of all, in 1998 or 1998, 20 years ago, I would already said, okay, if your shell doesn't do functions, then get another shell. And even in 20 years, you could think they could have refactored that in the meantime to be a little bit more modernly readable and stuff. But Jonathan asked, do you think everyone moves to ARM in the future? If yes, we're keeping Linux on... so the problem is this live stream, but maybe I answer quickly. So, so I'm actually live streaming from Linux M1, right? Previous videos. I just can't. I could self video here with super low tech solution of probably there, right? M1 Mac, I have a mirror here with that. Not everyone is. I think ARM will become more popular, and so will be RISC-V. That will be the two main architectures for the future. I would personally not really work on M1 Mac, although I got one because my company also still has Mac products. I said this before. The machine is relatively nice. It's not perfect. The keyboard feels flimsy and stuff. But the main reason why I wouldn't get an Apple M1 because it's so proprietary. I said this before in my M1 videos. I made some M1 live streams. I would personally, except Hector Martin also working on with Patreon donations. Even he only working for the money on that, and that is also the problem, right? That the community similar to this stuff, like Markan and friends and family, they spend all their lifetime even on. I think their donations are not even that high. I mean, higher than ours, but not full-time salary. And I would, in general, not support this proprietary hardware. I also find this GPU and audio and camera and stuff. And I would personally, if my company would not have Mac products, I wouldn't give Apple my money. I would vote with my wallet. I don't like very many things Apple is doing in their locked-in ecosystems. And so I would basically, if I would have totally the choice, and you have seen this here usually with RISC-V and stuff, I would normally not get the hardware. Even if in Lenovo AMD 5900 something is less performance and not as energy efficient, I would in general rather get the standard hardware. Also for you today, I mean, why would you want this, right? You basically, if you or let other people work on this, those people like us here with this kind of debugging and making the world a better place, they basically put all their hard work and free time, their lifetime in this, and making Apple richer, right? Apple gets all the sales and money so you basically, if you get the machine today, you can't really use it much except for unaccelerated terminal thing. You have no graphic acceleration. Graphic acceleration probably takes years to be fully useful, plus hardware video acceleration, not GPU 3D, but video encode and decode if you wanted to watch YouTube and stuff. So for Linux, highly inefficient and in general, as usual, if I summarize this, 5 minutes gone. So yeah, there you have it. Probably I should make a dedicated video for that. Dash expects 5. I mean, yeah, x86, given how high performance and industry standard it is, x86 will be for sure around for 10 years, but ARM and RISC-V will become more popular. I think even due to the licensing fees, I expect ARM to become the next 86 in a decade, and RISC-V similar. I said this before, it also takes a decade for RISC-V implementations to become as super scalar and speculative and stuff, to be as high performant. But even the next years, we will see the vector extension and hardware virtualization based RISC-V stuff. But even they will not be as fast as latest state-of-the-art x86 and ARM silicon due to just the decades of head start they had implementing that. So yeah. What else do we have there? Stuff. What window manager would you recommend for T2? That depends. On my vintage hardware, I just use Blackbox. On modern hardware with Wayland, I use Sway for live streaming. If you want snappy stuff, then Graphic Blitz and Bang, then GNOME and KDE. Gen Multilib last updated in 2017. I mean, that it's last updated in 2017 is not even the worst thing. It's maybe nearly bug-free or so, but yeah, not easy to follow, not easy to debug. In some lines, even I need to think. I mean, not this, but again, in some lines, you need to. What are they doing there? Are they this? Oh my god. Yeah. What else do we have there? Fine, less dependency easier to. What else do we? Something. Heard. What else do we have there? Is Xmonad packaged? No, but probably not too hard to package. If you want packages, just open a GitHub issue or submit patches and stuff to Discord and so on. And yeah, anyways, that's for the video. I have some other stuff to continue and keeping this short. Yeah, keeping this short with 45 minutes. But yeah, this is basically the stuff infrastructure people working on GCC LM Clang also do and spend their time on. And this is basically adding insult to the injury, how you can waste your lifetime 20 years later. Still, you find crazy stuff like that. But yeah, maybe for today, I'm not sure if I'm a little bit mixed of I burned 6 hours on this bullshit, and should I now spend another hour of maybe getting this to work, or maybe I rather go back to just trying to patch Clang for now. But I would, as I said initially, I would not call this installation naming amazing if you have 64-bit architecture, triple directories with 32-bit binaries in. That triggers me a little bit and is of course a little bit strange, as I mentioned, that if you configure your compiler to 32-bit default, that then the same compiler, the same stuff, the same directory names, and the only difference is the default, that you get a different directory layout there. That is, in my opinion, not really desirable. And this is also like all the big Linux distribution vendors like Red Hat, who had PowerPC and Spark support, or SUSE here with PowerPC. Nobody of them, and they have the high-paid GCC developers there, multiple GCC developers, SUSE, Red Hat. Nobody ever bothered to improve this, right? So like, yeah, YOLO, whatever. It's installed, it's built, it's fine. It's year after year. I'm surprised that 20 years later, unsuccessful woman YouTube distribution guy here, I still find this stuff. I even invest 6 to 7 hours, and at the end of the day, it's like, yeah, man. I mean, maybe even those people from SUSE and Red Hat even tried, right? I mean, maybe they also burned 6, 7, or 10 hours, multiple work days at work there at SUSE and Red Hat, and gave up. Maybe 10 years ago, it's like, you know what is it? Let's ship it, right? Ship it. Yeah, maybe, who knows. Something, Red Hat cares that much, Docker image, something. So yeah, I think there was some minor thoughts that I also want to mention, but I have to check my girl called, so it's better check what, probably she's already not happy that I didn't pick up. Anyway, don't forget to share and subscribe if you want to support all those efforts. It would mean a lot if you share, like, and subscribe, and if you can, Patreon, even $1 a month or something would be amazing, because as seen here from these videos, I obviously spend way too much of my time on this stuff that, nah. All right, I wanted to mention, I remembered, I wanted to say, we even fixed G5 optimization, right? 1 year, I think last October, so over 1 year ago, maybe 14 months ago, live on this channel, we fixed GCC is miscompiling glibc if you optimize for G5 or cell, at least G5, maybe cell 2. I sent this upstream, right? I debugged that, maybe it took 30 minutes or so, not as long as this. I spent another 30 minutes or so on that. 1 year ago, right? I sent it to Bugzilla. I logged in there. I recovered my bloody account. Each time you want to submit something, you need to recover your account because you have like 50 of them for all the projects. And I spent the extra 15 minutes to fill out the bug report stuff, and nobody cared, right? 1 year later, only because someone on Twitter was triggered about something, and I replied there regarding, I don't even remember what exactly that was, but maybe it was something with Free Software Foundation contributing or sponsor or something or whatever. And I applied there, yeah, like this patch, like, or this 6 months old or something, right? Half a year ago. And even though I triggered someone on Twitter who even pinged them, right? And added, because it doesn't even apply anymore, this patch, right? So 14 months ago, I made a patch that doesn't apply anymore. Of course, I rediffed it into 2, but nobody upstream cares about PowerPC 64 G5 optimization. And I rediffed it, and this person on Twitter, maybe some GCC follower or something, even added a link to the Bugzilla. Hey, ping, ping, hello. Oh, actually, you know what? This person on Twitter told me, yeah, but have you also sent an email to GCC patches or something? It's like, yeah, do. I should fill out a bug report. I should use a web form and an email. I mean, how much stuff should I even do? But I even did this, right? Then I even wrote them on Twitter, yeah, excuse me, here's my email to GCC patches, right? I even did it. I did web, I did email, and 14 months later, YOLO, whatever, nobody cares about PowerPC anymore. And that is the sad thing, right? You spend all your time and efforts, and at the end of the day, nobody from the freaking Free Software Foundation even applies your bloody patches. And then you wonder why I'm not upstreaming most of my work, because it just doubles and triples my work for no gain, right? I get nothing. I only have more work of stuff not being applied, and I can also not send it in, right? But anyway, if you want to support the stuff, it's nicely sorted into 2. Everyone can cherry pick the stuff. I mean, there's a reason why Red Hat IP address space is #1 surfing our websites. You're welcome, mates. Happy to cherry pick. Happy you learned something, and yeah, hope to see you next time for more videos and in-depth stuff to come.